Good morning. We hope everyone is doing well. Welcome to the first in a series of educational webinars focused on solutions for the power industry. My name is Kevin Johnson, and I, along with Kurt Traub, will be your host for today's webinar. For your convenience, and should you have any follow-up questions, our contact information is provided at the end of the presentation. I also wanted to remind you of our special offer related to a no-cost instance of PowerView. We will have more to say about that at the conclusion of the webinar. Today, we are presenting PowerView as a workforce collaboration and data fusion solution. At its core, PowerView is a geospatial visualization and data aggregation tool. PowerView is developed by power system engineers for power systems engineers, owners, and field personnel. More specifically, PowerView is developed to facilitate transmission, distribution, substation construction, as well as lifecycle asset management for investor-owned, municipal, and cooperative utility owners and service providers. It grew out of the need to increase project efficiency and the ability to communicate cross-organizationally. PowerView allows users to work in a collaborative manner, both internally and externally, with field personnel in real time, all from a single platform using the latest versions of the data. Before I turn the presentation over to Kurt, I wanted to share and define a few terms as they apply to the PowerView solution and as will be referenced throughout this webinar. We won't read over each definition in detail now, as most of the terms are familiar and self-explanatory. However, we will revisit them throughout the presentation. For the remainder of the presentation, we'll focus on 4 key areas or targeted applications whereby PowerView adds value to an organization by increasing efficiencies, avoiding costly errors, reducing field time and truck rolls, and expedite system restoration in the event of an outage or storm-related event. Additionally, we'll touch on PowerView's capability as an asset management and workforce collaboration toolset. PowerView was initially developed to support engineers, clients, and field personnel with the construction and management of transmission and distribution line projects. PowerView directly imports design models from PLS CAD and has the ability to import data from other database sources and CSV formats. This results in an intelligent geospatial and visualization representation of the project, complete with pertinent project documentation, including framing diagrams, plan and profile drawings, sag tension and stringing charts, project-specific construction standards, inspection reports, permits and approvals, photos, and so much more. Additionally, PowerView provides construction and project status updates in real time across the organization. Field personnel have the ability to upload documents, make field notations, and add photos to augment the data. So let's dive in and let me introduce Kurt Traub. Kurt is the Vice President of Transmission and Distribution Line Engineering. Kurt is a licensed PE with more than 23 years of experience in his field and spent approximately 9 years at a major investor-owned utility before joining Empirical as a founding principal. Along with our in-house software development team, Kurt is the chief architect of PowerView solution. He continues to provide guidance regarding the continual feature enhancements to PowerView to increase its value to the end users. So without further ado, I'll turn the presentation over to Kurt.
All right, thank you, Kevin. Good morning. Today, I want to spend a few minutes on a general walkthrough of a demonstration project in PowerView. We will use a few sample projects to show you how a project looks in PowerView and some of its unique features and capabilities. We will then move on, getting into specific topics and benefits of PowerView as it applies to the previous targeted applications. First, we're going to discuss the data fusion of a project on an existing line. Data fusion is simply getting the data and drawings of an asset together at a geographical location it is to be used or installed. So you can see the project here, and I'm going to zoom in and kind of show you. It's a typical KMZ that we pull out of PLS CAD. However, we can click on items, and we also have what we call icons or place marks that gives us information about each structure location. I click on this hamburger in the top left, and I can do a zoom extents to kind of show you the whole project. As you can see, this is inside of our web browser for PowerView. You do have the ability to download this to a KMZ and see it in Google Earth, but we have a lot more capabilities to do things inside of our own web browser here. Next, I'm going to show you an icon legend, so you can see it in this location. And I do want to mention that this is strictly a demonstration project. I don't want anybody to think that we use 6 or 7 different structure types and 6 or 7 different foundations on a project. We created this project strictly for demonstration purposes, just so you can see the versatility that PowerView has on a project. So this first view is strictly what type of material each structure is. You can see we have some concrete structures, some weathering steel. Of course, we have some galvanized steel. We have a couple lattice structures in here and a few wood structures in there. What if you're the foundation contractor and you want to see exactly what foundation types you have in a project? Well, we can change those place marks and icons to show exactly that. You can see exactly where we have drilled piers. A lot of the tangent poles are direct embedded. Those towers are on spread footing foundations. We got a couple of helical piles as we cross over the interstate here, and so forth. But what if you're the framing guy, that you're going to be, framing structures and standing structures? We also have the structure name, and so here we can see exactly what the framing of each structure is. See, we have a double circuit line here with tangents. We've got some dead end and some running angle structures. Here's those 2 tower structures. And so we can get a pretty good idea of exactly what the framing is throughout the line without having to zoom in and see the structures themselves. What if you're the communications guy on the job and you just want to know exactly where our splice points are? Well, we can do that too. We can see exactly where our splice boxes are placed. So communication guys can look and make sure they have access to those locations and also run their calculations for losses to make sure that they're good there. We put the structure number on it, so it's very easily identifiable to where those splice box locations are. What if we're in the planning stage and we need to know exactly how we're going to get each structure or each caisson or whatever to the whole location? Well, we can also do structure access. In this instance, we're showing, we got a couple of them that we can actually get there by land crane. Some of them we're going to get there by helicopter and fly them in. Or maybe we're in a swamp and we need a swamp buggy to get to a few structures in here. Again, all these place marks and all this is customizable to your project. You can create icons for whatever instance that you're going to get that structure or caisson to that whole location. We got some other ones. What if you just want to know where we have a single circuit versus double circuit? See, we have a double circuit line here, goes into the station, then we go single circuit to this other substation. You can also do it by pull point. So a lot of utilities come to us and say, okay, well, where are you planning on setting up your equipment to pull? So we can identify those locations too and say, okay, you have structure 1, we're going to pull this way and we're going to pull that way to put those sections in. So again, just different ways that we can show different information there. And I think that covers them all. So I'm going to go back to structure name. I'm going to zoom in here and get us a view in 3D. And now I can click on stuff. I'm going to click on structure 287, and it pulls out this draw here and gives me all the information on structure 287. Now I can lock in on that structure. You got a little lock up here, and I can lock in on it and show exactly that structure, and I can pivot around that structure. Or if I unlock it, it kind of gives me the flexibility to move around how I want to. So that structure 287, we got a weathering steel pole. Here's the framing name on it. It's an engineered pole, 110 foot tall. It's embedded, 15 feet. Got cross rock backfill. We got a couple anodes on it. Here's the pole weight, tip diameter, butt diameter, and so forth. So all this information is completely customizable to whatever you have in your PLS CAD model. So if you want additional information, you can add. If you want different information, this information in here is completely to what you want. And then we also have the ability to put drawings in here. So structure 287, we click this and we open up the framing drawing for that structure. We can attach the foundation drawing. It's a direct embedded pole, so we got a direct embed drawing, find the structure number, and you got the information for that. Pole fabrication drawing. Some jobs you have over 200 poles, so good luck trying to find a pole fabrication drawing in 2 or 3 inches. Here we put it at a click of a button. You can pull up that drawing instantaneously. Last one is an insulator drawing. Click on that, you got the insulator assembly. We're highlighting the conductor that we're using, so it's easily identifiable by the construction crews out there. It's exactly what parts they need to make up that assembly. So a different structure here, we'll show this dead end structure. Again, same type of information. It's galvanized steel, dead end structure framing. It's an engineered pole, 95 foot tall. And then we got a drilled pier though instead of direct embed. 6.5 foot diameter by 29 foot long with a 2 foot reveal. And here's where we're identifying that this is a splice box location. Again, we got the weight, tip diameter, and all that kind of stuff. Of course, we got a different framing drawing here for that dead end. We got the foundation drawing. Now it's a drilled pier, so we got a different foundation drawing there. We got the anchor bolt cage. Since it's a drilled pier, we can put anchor bolts on it. And then we have the insulator assembly for that dead end with the conductor highlighted there as well. The other thing we could do is actually click on the conductor now and get conductor information. So click on the conductor. Again, it pulls up on the draw here. We're on section 25 out of PLS CAD. We're running a Bittern ACSR conductor here. And this section that I clicked on, you can see when I click on it, it highlights. And that section is from 286 to 293 and gives us the rolling span. So we can also attach drawings to that section. Here we can attach the plan and profile drawing. And if it's more than one drawing, we can attach 2 drawings, which you see here, we got 2 drawings. But we can also attach the sag tension report or the stringing report to show out in the field. You know, here's 286 to 293. Here's a Bittern conductor, and we got all the information for the sag chart there. The other thing that this is really good for is revision control. If you was to change out a drawing or change the plan and profile drawing or change the sag chart, we can easily upload the revision, and the next time the guy's out in the field, click the link, they're going to get the latest revision. We're no longer emailing drawings and having them change out in the books out in the field with paper drawings. It's the link there, and they will get the latest drawing from there. So what else is included in a construction package? One is phasing, and you can see the phasing we got here is colored. So that kind of takes the place of our phasing diagram. As we get to the substation, it's very clear how those phases roll into the substation. And so that kind of takes the place of our phasing diagram in a construction package. What else do we have in a construction package? We typically have construction standards or maybe detailed drawings, where our little power view guy here kind of holds all that. So if I click on him, he's going to pull up all my construction standards. So if I want to see a general concrete construction standard, I click that and it pulls up my general concrete construction standards, so we have access to that. Or maybe you want him to hold just some general detailed drawings, maybe the grounding drawing to show how a steel pole gets grounded on a drill pier. You know, so he kind of holds all that extra information that's kind of universal to the entire project. Okay, so from here, we're going to go into another project. Give me 1 second to switch that. Move this up, move this guy in. Okay, so this is another project, and on this project, we're going to talk about project management and construction management and how Power View can be used for that. So before I get into the project itself, we're going to click on milestones here. So this milestones tab allows us to create milestones for a project, and it's completely customizable to what you want. This is what we decided on some of our projects, just to be able to track status of structures and conductor. So red just means we received the pole. Magenta means we spotted the pole at the whole location. Orange means we framed it with insulators. Drill pier was installed. Here means we set the pole in the ground or on top of the foundation. And complete means we strung wire and clipped it in and the structure is complete. We can also keep status of the conductor as well. Again, these are interchangeable. We can change the name here. We can change color. We can change the order. We can delete milestones, or we can add milestones. So customizable to your job. So we're going to go back to the viewer now. You know, up here, I'm going to show you the status legend that we just looked at. So again, milestones and the colors we chose. And at the bottom, you'll see we have a timetable. I'm going to go full screen here so we can see it all. And I can move this timetable. We can see we started in August. This is an old project. This started in August of 2016. As I move the timetable down, you'll notice in about August 22nd, 23rd, all the icons turn white. Well, that signifies that we started construction. And now we're going from that construction package to status of the project. And as this timetable moves, I'm going to press play, you'll see the colors of the icons will change color based on the status of that structure. You see we received a lot of poles here. There was the eagle's nest here, so we got this section in quick. And as it goes down the line, I'm going to move it a little faster here, you can see the status of the project going along. You can see we started setting a lot of poles around May. By the end of July, you can see the wire crew gets on site and starts stringing the rest of the line until we complete the job in late 2017. So again, we could stop this at any point and see exactly the status of each structure. So right now we look at September 15, 2017. We can see exactly the status of each structure on the job. So if I'm the construction inspector on the job, how do we change status? How do we do things once a project starts? You know, structure 26 here, it was actually completed, but I pulled back some statuses so I could show you what we do out in the field once we start a project. So at structure 26, I click on it, and I'm still getting that same information out of PowerView, PLS CAD. But now I have some pictures, still have all the drawings, but down below I have statuses. And you can see the drill pier was installed on October 11th. We received the pole on August 27th. We spotted the pole on September 14th. We framed it on September 15th. And if I take this little timetable and go back, you'll see right now I'm at September 5th and it's red because that was the latest status. But once I get to 14th, 15th, you can see that color of 26 change to spotted and framed. So, and this is happening in real time. So as our guy out in the field is changing these statuses, the engineer, project managers, and the stakeholders back at the office can see these changes happen in real time. So let's say we went ahead and set structure 26. So I come in here, add, and I'm gonna set structure 26, and I'm gonna set it close to the date that it actually was in 2017. We'll just pick like October 13th, and we'll save it. And you'll see that status appear in the box here. And then as that timeline goes by and we get to October 13th, you'll see the color of it change to purple. So other information we can put in here is notes. So at structure 26, if we had a landowner issue or any kind of notes we want to put in here. So, I'll put some examples in here. Mr. Henry requested that we map around his property. See attached landowner settlement. Or if we had some RFIs, RFI 11, pole seems to have more deflection than typical engineering to review. Just some examples there. At the same time, we can upload forms to that structure. So here we have concrete break tests. I can open this up. We'll open up the final one. And we can see the concrete break test for that drill pier we put in there and store all the inspection information at the location it's being used. At the same time, we have like foundation report. We can view that. So anything out in the field, we can either take a picture, scan it, or we can actually create a template that they can fill out from their laptop or computer. And then of course we have the pictures that actually show up as thumbnails here. If I click on a picture, high resolution, you can zoom in and see everything on the structure as well. Okay. From there, we can also run reports. So if I go to reports here, and I ran a couple of sample ones just to save some time, but I can download this report. It automatically generates from all the statuses that we have in there. And this report is for every structure. So you can see at this point, we're 97% complete. We have all these structures, and we go each structure, and it tells you what the last status was on the date that last status took place. Again, this is just a general to show that we can run reports out of here. We feel that every utility is going to have different requirements for reporting, but just to show you that we can generate reports from the data that we have. All right, so moving on. So now that we've established a basic understanding of PowerView as a document aggregation and project construction management tool, let's move on to some additional value add applications of PowerView as it relates to asset management and workforce collaboration. Asset management is defined as the practice of managing the entire life cycle from design, construction, commissioning, operating, maintaining, repairing, modifying, or replacing and decommissioning of transmission, distribution, and substation physical and infrastructure assets. Our next example will demonstrate PowerView as a asset management tool. By having transmission and distribution lines, substation, and other related grid assets associated with PowerView database, it allows system owners to manage those assets for various activities, including asset inventory, asset maintenance, periodic inspections, and storm and outage restoration. By linking documentation to a geospatial asset, we can access relevant asset data and documentation to include such items as bill of materials, detailed drawings, historical work orders, inspection reports, field notations, detailed photos, and other information or documentation that may be pertinent to field personnel. We're going to go back and do a live demonstration. I'm going to come back to this project, the demo project we were looking at earlier. I'm going to zoom extents here. I'm going to come down to this tower, structure 72. I'm going to click on that. And so now we're looking at, we're pretending this job now is a job that was built long ago. In fact, let's pretend this job was built, this line was built in 1970. Okay, so now we're keeping asset information and keeping historical data about this line. So I'm going to lock in on this structure 72. And of course, you see the information that we pulled in about that structure. And we still have the drawings. We still got the framing drawing of this tower in there. We got the foundation drawing, insulated drawing. But now in our notes section, since this is an existing line, we can keep the history of this line in that notes section. Kind of see it as like our revision of, but now our revision is not over the whole line on a drawing, it's at each structure. So we can see in 1970, this tower was installed per this structure data sheet 218057. August 1st, 1985, they added counterweights to the insulators to prevent swinging. In May 5th, 1995, they replaced the insulators, went from ceramic to polymer insulators. And then in January of last year, they did an aerial inspection done on this tower. You know, this may be small and tight, but so if you want to see this in a little more information, you can actually come over here to that structure 72, and we can view that in a little bit better format where we see it in this way. So each structure in the line has their own page where we can see all this information and all the data. But also look at the uploads. You know, here's the SDS that was referred to in that note section. You know, so we can still go to the old drawing and pull up the historical data. Here's that inspection form that was done on the tower that was done January of last year. So we can attach inspection forms that have pictures and everything else of the tower. So again, you know, what you attach and which information you put in here is strictly up to you in every utility, but you have the ability to do so. All right, so we're going to go back to the viewer and show you a couple of other instances. We're going to scroll down into structure 274. And again, just to show you a different structure, same type of information though in the note section here. You know, May 5th, 2017, we replaced damaged insulators from Hurricane John, replaced with the same insulator assembly and put the catalog number for that insulator assembly. And 2019, pole ground connection was damaged and replaced. At the same time, we could do uploads. You know, we can upload that inspection form that was done in 2019. We can, you know, attach a new picture after the storm went through to show that those new insulators have been installed. You know, again, just some different examples on the way the program can be used. It's also not just limited to structures. We can click on a section. So we'll click on a section from 274 to 278. And again, in the note section there, we can put in June 29th, reconductor. Section was damaged and reconducted with 1272 ACSR. And of course, we can upload an inspection form here and view that to show, you know, that inspection form was done, you know, the weather and the temperature and everything, that it was strong. And then this is actual survey of the sag to make sure it was sagged in appropriately. Again, those forms can be attached there as well. So moving on, we're going to go to back to here. So PowerView has the ability to add in custom asset types. These are referred to as custom project. Substation assets are just one example of a custom project. So you notice up here we got create project, we got PLS CAD project and custom project. We've been showing so far as PLS CAD type projects, but now we have the ability to do custom projects. So if you don't have a PLS CAD model, or if you have other like a CSV file that you can import that, we can now import that. So first we import the CVS file. So we're going to show this demo substation project. So the first thing we do is upload the document, which is strictly just a CSV file that gives us all the information and asset information. The assets are related in a parent-child relationship, with the substation being an example of a parent asset, and then the breaker, switch, transformer, all being a child asset, and that can be grouped and associated to the parent asset. All the previous document types can easily be associated and linked to these specific assets, just like in the previous example. So here, you know, switch, I'm selecting a little icon, I'm selecting a color for a substation switch. Of course, we got plenty of icons that we could choose from that represent that. Same thing with breaker. We do breaker, and we can do transformer or whatever here. you get the point. Here at breaker, we can actually put in some default asset information. I know that every breaker on this job was the same one, so I can put this in there, or we can read this from the CVS file automatically, so you don't have to manually do it. We try to automate as much as possible, as long as we're given that information in that CVS file. You can also attach certain links and drawing links. So once we finish this step, we go to place assets, and it's kind of a preview of what your project's going to look like. I'm going to zoom in here. We'll get some aerial photo in there. And so now I can click on different switches or breakers, and I'm going to get the information that was inputted. So we'll click on this J1005. So this is read from that CVS file. We got the longitude, latitude. Here's the icon that associated with it. Now here's all the information that was inputted or read from that CVS file. Southern State switch, 3000 amp horizontal mount. And then we got all the drawings of that switch in here. So this is kind of where we add all the information, kind of like the final touch before we finish the project. But we can also add assets. So say if we miss this breaker here and it's not part of the CVS file, well, I can go ahead and add a breaker to this project from this location geographically. So I'm gonna say I want a breaker. I'm gonna add it. I'm gonna add it at this location here. So there it is. It's an asset. I'll probably name it J110. I got one of those. We'll do that. Got this. Of course, it gives me the default of all the other breakers on the job, and then it also defaults with all the other drawings that we have with that job. So again, we can just add that way too, in case the CSV file does not have information. So we're going to go look at this project now. That's just the way to set it up. Again, you can set up milestones here and everything. I'm going to zoom into here and show you what we could do with substation assets as well. Like I might have zoomed out too far. Let's see. There we go. Okay, so here we are at that substation. And now I can click on that information. Again, we're getting all the default information. And now we can attach pictures. So here's a picture of that switch. 245 kV, 3000 amp switch, the horizontal mount, center break. And we got drawings. So here's the switch drawing. We got the switch stand that it's sitting on. Again, getting all that information at the locations being used. Here's the switch foundation. We can put in there. Same thing for breaker. Click on the breaker. It's a Siemens breaker, 245 kV, weighs about 12,000 pounds. We got a picture of the breaker that was installed at that location. We got the breaker panel, if you want to see a picture of the breaker panel in there. Again, just easy way to access information. Guys out in the field taking pictures, we have back at the office can view it really quickly. Breaker drawing. We got the control AC schematic that we could put in there. So, the amount of information you put in here is strictly up to you. You can put as many drawings as you need to. Control house, again, we got a picture of the control house. We got the control house drawing. We also have this other one called demo substation. This is just an icon that kind of covers the entire substation. So we got a picture there of the entire substation, or just a general overview of the substation. But at the same time, we can attach drawings that are associated with the entire substation. Maybe you got your electrical arrangement in here. Or maybe you got your one line in here. Kind of give you that information. Again, this stores, and this is like your depository for all your substations and all your lines, that you can easily access this information without having to go through folders to try to find the information. Here's a profile of the substation. Foundation plan, grounding plan. All that information can be attached here and put it in more information. Another idea is taking this control house and putting all your panel drawings and all the relay protection drawings in there. I think we get the idea of what we can do with it. There's plenty of opportunities that you can add a lot more drawings and everything in there. So last demonstration is going to be on, say, a distribution line. So this demo distribution line. So say if you had a project that you don't have a PLS CAD model for. Maybe you have a database with all your structures, either transmission or distribution. We could still pull all that data in and still be able to show those assets in this way. So again, we had this project, we're simply uploading a CSV file. We can upload hundreds of polls. This job, I kept it kind of small for demonstration purposes, about 50 sets. Every asset here, distribution line, of course, is a poll. So we're assigning an icon and a color for the wood poles. If you wanted to break this out to tangent poles, dead end poles, you could do that. We also set in some default information. So now we can go to the project. And you'll see all 50 assets come in here. So you can easily see the benefit to a lineman, substation field tech and other personnel having data at their fingertips, having the ability to access relevant data without having to go to the office and pull up potentially outdated data, can save truck roll time, avoid field delays, and potentially costly errors. So we can zoom in here. We'll click on any of these structures, click here. And we got all information about this structure here. We got 215, 513, 531. It's a wood pole, 60-foot tall, class 1. And this was a storm hardening project. So this is where we're modifying the existing line. So here we're saying we want to install a single 10-foot dead end fiberglass arm on the top and a double 10-foot dead end cross arm fiberglass on the bottom. We're also installing dampers on the phases. And then we're also installing a secondary riser at this structure. So we can, of course, attach a drawing of that secondary riser and how it's made up. And we also have what we call a pole summary report, which kind of gives a summary of all the loads on that structure. And we can attach those. We can attach inspection forms here. Again, just getting all that information at the location that we need. Look at structure 62 here. Here we're reusing some. Again, we got an existing transformer, so we put that transformer drawing here with the bill of materials. 61. On here, we got install a single 10-foot tangent fiberglass arm at the top, and then we got to install a dead end fiberglass at the bottom. We got pictures, so we can click on the picture here when we did a field walk or from aerial photography. So you can see the top arm tangent, bottom arm dead end that we're replacing. So all that information's here, and we can add more, we can take out some, but all that information is in there. So our final topic for discussion is that of workforce collaboration. As the definition suggests, it is the ability for multiple teams or individuals to work collaboratively on a project. With real-time updates and remote worker access, PowerView is ideally suited to facilitate cross-organization engagement on multiple projects built or imported into PowerView. With real-time updates, PowerView allows teams to work together and share a common set of data regardless of their physical location. In these type of projects, we have environmental involved, we have land people involved, we have a lot of people involved in these projects, and to put it all in one location that everyone can access the same information is very helpful. Back here. So although originally built to integrate with PLS CAD data, PowerView is not limited to PLS CAD data only. Grid Intel has been working to develop multiple data exchange, input, or export of capabilities. Currently, data can be imported into PowerView from PLS CAD, CSV formats, and baseline Esri data. As part of our continued development efforts, Grid Intel is currently working on additional data exchange models, including a broader integration with GIS data, importation of LiDAR data, and custom scripting for user-defined data fields. I want to thank everyone for their time and attention today. I know everyone's busy right now, working from home. I hope everyone's safe. And I hope you give Grid Intel a chance to prove what PowerView can do for you and your company. So from there, I'll turn the presentation back over to Kevin.
Thank you, Kurt. I think we have a few questions that came in, so I'd like to just maybe go over them. So one of the questions we had today was, can anyone make changes within the PowerView program?
Not everyone. So first you need a license to the program. But the way we have the program set up is we have 3 different license types. We got what we call a creator, which is like the administrator, and that creator has access to everything. They can create projects, they can upload drawings, they can change status, they can upload inspection forms and so forth. The second type is a contributor, and this is more like our field guy, our field inspector, or construction inspector, construction manager. He cannot create projects, but he can change status and he can upload drawings, okay? Or upload inspection forms. He cannot change drawings, only the engineer or creator can do that. And then third license, a viewer license, which is strictly that, just viewing the information, viewing the drawings, viewing the statuses, and cannot change anything. So we do have that security in place that you can set different licenses for different types of people that are going to access the project. And then each client is going to have their own dedicated PowerView instance. So, you know, data from one utility is not going to be merged with data from another utility. You'll have separate locations.
Okay, good. And we have a second question. Can PowerView be used for post-storm damage assessment?
Sure. You know, if you look at an existing line and you have all that data in PowerView already, you know, you send a field crew out there with a tablet or a laptop, you know, they go out to that location, they have all that information with them. They have the drawings with them. They have the information about the structures. They can be able to see exactly what structure number it is down without approaching the pole or the wires that are down. From there, they can actually, you know, take pictures of the damage, put some information in there, and fill out a form and upload it to say exactly what damage is done in each structure. Then once they come back and fix the pole, we could actually, you know, take a picture and upload it to the exact location of the fix. Put information in there and drawings in there of what the fix was. You know, there's been plenty of times where we're doing jobs that are 5 years down the road or 10 years after a storm, and what's out there is not what's on drawing. So this would be a way to be able to, you know, make sure that data is being maintained and, you know, carried through for the next project.
Good. All right, well, here's another interesting question. How is data accessed remotely by users, especially those users in the field?
Yeah, so as you can see, this is all web-based. So just as long as you have an internet connection, you can access it via tablet, an iPad, laptop, and you'll get those real-time updates from the office out to the field and vice versa from the field back to the office. And that's where the workforce collaboration comes in between the two. You know, we have different inspectors and different managers have their own work method, right? So some of them like to carry around the tablet the whole time and you know, change status while they're out in the field. Some of them will collect all that data and go back to their, you know, trailer at the end of the day on their laptop and upload that. So you can access it from any type of computer and be able to see the information.
Okay, well, that's all very good information, Kurt. Thank you. So to summarize, PowerView helps the end user to manage and maintain assets, coordinate data across the organization, improve project accuracy, aggregate data, provide visualization and geospatial platform, and provide for storm and outage restoration. We'd like to thank you for your participation in today's webinar. As stated in our invite, Grid Intel will be conducting several webinars related to PowerView and to help the industry through these challenging times. Additionally, Grid Intel will be providing access to a limited time instance of PowerView at no cost. Should you have any additional questions or need to set up a more specific detailed demo or to request a no-cost instance of PowerView for your team, please contact our sales team at the email there, kevin.johnson@gridintel.com. And you may also contact Kurt directly at ktraub@gridintel.com. On behalf of Grid Intel, we want to thank you all for your time today. From our family to yours, we pray for your continued health, safety, and blessings as we continue as an industry to address the effects of the COVID virus. Have a great day.